Hi, Dr. Sergey and Dr. Paulo. Let's talk about my project and dissertation. The result of my project is a GUI application for heart attack prediction. The model for prediction is created by PyTorch, and the GUI is built by Qt. The whole program is written in Python language. At first, I would like to talk about the background and motivation about this project. By WHO, cardiovascular disease is currently the leading cause of death, with an estimated 17 million deaths per year. Even after perfect and advanced treatment, more than 50% of survivors still can't take care of themselves. Heart attack in CVDs causes more than half of the deaths in most countries around the world. People with heart attack or high heart attack risk need early detection and management. But it is hard for doctors to give a prediction of heart attack chance. Some studies use many machine learning methods to help the prediction, but the research using deep neural network is relatively rare. Deep neural network often has better performance than shallow learning methods, especially for big data nowadays. To make the model user-friendly, a GUI application can help a lot, and it can also help to store or collect the data from the users. Therefore, using deep neural network and training it for datasets about heart attack and create a GUI application to make user easy to use may help people a lot. Then, let me show the process of prediction. Users can import their information by keyboard and mouse. Yeah. And after completing all the imports, they can click the push button to get the result. If the output of neural network is smaller than 0.5, the result will be less chance. Otherwise, the result will be more chance. Some norms of input information may be difficult to understand by normal people, and the project has a help menu, and it has two versions, Chinese and English, to help more users. It will tell people what's the meaning of the import. Yeah, and if the user has a different result from hospital or doctor, they can change the result by check the prediction. And the program will tell the user that you have successfully changed the prediction to another situation. The users can save the output and input information together by save function. And if they do not have a prediction yet, the application will inform the user to complete the prediction first. And if after you choose to check the prediction, the save file will save the output after checking. It will create the CSV files called prediction. Yeah, and the output is be checked. The program also has an upload function, but it's a great pity that I'm still in China and I do not have my own server. So I can just put my email address here. However, I have uploaded the whole program in GitHub, and everyone can use the program and download it or give me any information about that. The logo of the application is a beating heart, which means good wishes to users' heart. At last, I would like to show the process of building of the neural network. At first, the program should import some basic neural network module and machine learning modules, and then doing some basic data processing, read CSV files by pandas, and check the first 5 lines, check if there is any missing values. Okay, there is no missing values. Then split the data for output and input, and transform them to an NumPy array object to use standard scalar to standardize the input. The scalar of this input can be stored for a new input to use the same scalar in prediction function. Yeah, and I split the data by 20% of output. The 80% is train set and 20% is test set. Okay, after processing the data, I can convert the NumPy array object to PyTorch data load and confirm the batch size. Yeah. After all, I have to create a neural network model. I just use the nn.module class and build it. I can freely adjust the number of hidden layers, the number of neurons, and the activation function. Basically, the activation function of hidden layer is ReLU, and the activation of output layer is segment, because it is just a binary classification. Yeah. These are other neural networks I have built. And import ensure the input size and the output size, and we can create a neural network. And the loss function is just a binary cross entropy because it is a binary classification. And the optimize is Adam, and I can choose my learning rate and weight decay in these parameters. At last, I should ensure the number of epochs for training. I define a train class by myself because I need to get the start of time and the end of time, and the loss of and accuracy changes during the training process. The other part of this method is just normal, forward, backward, and optimize. Okay, let's begin to train. It just takes very little time. Then, according to the collected data, I can get the plots of loss and accuracy during training. And I can change the parameters such as optimize the learning rate and weight decay, number of epochs by the plots. Yeah, and then at last I have to evaluate the neural network. The network should have the evaluate function because it will have some weight decay or dropout method. At last, I can evaluate the quality of prediction by classification report function in sklearn module. In most of time, I just look at the accuracy of test because the data set is a very small data set, and I can easily save my neural network. Okay. Yeah, and I can load the scalar by pico load function and load the net by torch load function. Yeah, and I can use it to predict the results. That's all. Thank you.